Okay, so we're going to go over basic ideas of simplicial homology. The basic idea is essentially determining certain topological invariances of geometric objects by essentially filling them with triangles. So if you have a trapezoid, the one I have actually on the right, it's not a very good one, you can essentially draw this diagonal, and now you have two triangles basically filling it. You could use this diagonal as well, right? So that's sort of the idea of triangulation, to fill something with triangles. And now a key idea, so how do we represent that algebraically? We're going to write down the triangulation as basically the sum of the triangles with a bracket notation, in which we just write down the vertices in some consistent order. So here you have this bracket, and you have, so one order would be counterclockwise, E0, E1, E2, and so we can write it as, the first one as E0, E1, E2, plus, and this would be the second triangle, and so here you have E1, E3, E2. So we're going to write it as E1, E3, E2, and that's it. So that is basically writing algebraically what the triangulation is on the right. Now a key operator here is that of a boundary, an algebraic operator, which we show with delta. And so let's just look at what the boundary operator does algebraically to a triangle. I'm going to write it as E0, E1, E2, I'm going to put a hat here. I will explain to you what this is. Then E0, E1, E2. I'm going to put a hat on the second one here, and E0, E1, E2. I'm going to put a hat here on the third one. So that's basically, this hat means we are going to eliminate the first, and then the second, and then the third vertex. So what do we get? For this, we get, if you eliminate it, we get E1, E2. Here we get E0, E2. And here we get E0, E1. Now, here I had, of course, a plus sign. And here I also want to put plus or minuses to join the pieces together. But before I put plus or minuses here, let's take a look at what happens. So here we have E1, E2, and that's the line segment E1, E2. Here we have then, I'm sorry, this is E1, E2, this line here, and here is E1, E2. Then ideally we want to go from now E2 to E0, right? We went from E1 to E2, and then we want to go from E2 to E0, but here we have E0, E2. If this was E2, 0, then we would have gone from E2 to E0, and then we would have gone from E0 to E1, which would be this. So this is fine. This is not. And we can either switch the order, put this as E2 to E0, or equivalently we could put a minus sign, reminding ourselves that these have to be reversed. And here we have a plus sign, right? So essentially, if we follow this rule, drop the first, the second, the third, put a minus sign here, put a plus sign there, algebraically what we get are these three segments, and the interpretation is, of course, this triangle, right? Now so the boundary operator is what you intuitively think the boundary operator should do. It takes the triangle E0, E1, E2, which is this triangle, and then it isolates its boundary. So that's the boundary of the little triangle on the left. What about the boundary of the triangle on the right? E1, E3, E2. If we follow the same rule and making sure that you get, the right orientation, we'll end up with, we drop the first one, we get E3, E2, minus, we drop the second one, E1, E2, plus, we drop the third one, we get E1, E3. And see if we get a consistent boundary here. Let's just start from E3 to E2. Then it says go from E1 to E2, but of course we have this minus sign, so it really is from E2 to E1, so that's fine. And then from E1 to E3, right? So that gives us this. Well, what about the boundary of the whole thing? But the boundary of the whole thing is sum of these two boundaries. So if you put a delta here, right? You put a delta here, the delta of the sum is going to be the sum of these deltas, and so it would be the sum of this plus that. And if we note that here you have E1 minus E1 E2, here we have minus E1 E2, we have plus E1 E2, so this cancels with this, and we get just the remaining four terms, which is from the top minus E0 E2 plus E0 E1 plus here we have E1 E3 and here we have E3 E2. And let's see what that gives us. So you have minus E0 E2 here, which means it is a minus here. So really it's like going from E2 to E0. So let's start going from E2 to E0. Then you have E0 E1, that's E0 E1. E1 E3, that's E1 E3, and this is E3 E2, right? So essentially we have this boundary, which is also expected. So the algebra works nicely. The sum of the boundaries is the boundary of the trapezoid. And so let's see what happens if we take the boundary of the boundary. Now basically do the same thing. We will drop the first one, and then, So we have a minus sign, so look at the first term. We drop E0, we get E2. Just like before, there should be a minus sign on the second one. We drop E2, we get E0. So that's minus that. And then we continue, we drop this one, we get E1, minus, we drop that one, but with a minus sign, and we get E0, and we continue. And if we do all this and then look at the cancellation, you have minus E0, you have minus E0, but you have a minus here, so that's plus. Therefore, this cancels with this, and so on. We will see everything actually pairs up, and we end up with 0. And that, so let's write delta as delta squared. It turns out that if you have, instead of a triangle, you have a tetrahedron. So you have 4 vertices here, or 5, or 6, or n. Whenever you take the boundary operator and apply it twice, you'll end up with 0. So this is always 0. The boundary of the boundary is always 0. Or if you like, a boundary doesn't have a boundary. So that's it for now.